Hello everyone, I am Siddharth Kumar Jha and I welcome you in the Digital Image Processing lecture series. So, in the last video, we have talked about the how image formed using the illumination and reflectance. But here is a big question like how does a computer take a continuous real world image and convert it into the digital image made of pixels? Okay, so that's answer lies in the two important process which is sampling and quantization, and that's exactly what we are going to learn in this video. Okay, so without wasting time, let's get started. So let me open my notepad. So just hold a second. Okay, so let me write down the topic like image sampling and quantization. Image sampling and quantization. So the first thing which comes like why sampling and quantization. So the first topic is your like why sampling and quantization. So its answer is like in the real world images, like it is continuous in space like x comma y axis. So and intensity is your brightness. Okay, so let me write it down. So real world image, which is your continuous in space in the x comma y coordinate, x comma y, and intensity, which is your brightness. Okay, so computer can only store the discrete value. So we need the sampling and quantization technique. Okay, so computer can only store your discrete values. So we need the sampling and quantization technique. Okay. So the first thing is your sampling and the second one is your quantization. Okay. So let's understand. So discreting or the spatial coordinates. Okay. So let me write it down. So discretizing your spatial coordinates. Spatial coordinates. Okay, and quantization means you're discretizing your intensity values. Okay, so let's understand like image sampling. Okay, so let's talk about the image sampling. So the process of selecting discrete pixel, discrete pixel location, okay, in the image plane. So image sampling is the process, okay, to finding the discrete pixels location in your image. So in the simple word, you can say converting continuous coordinate x comma y into a grid or pixels. Okay, so converting continuous, okay, just write it down. So let's moving further. The spatial resolution depends on the sampling rate. So spatial resolution depends on sampling rate. Okay. So the higher sampling means more pixel, which means better detail. And the lower sampling means your less pixel, which means like loss of data or details. Okay, so for example, if there is a 1000 into 1000 image reduced to 250 to 250, suppose there is your image whose was like 1000 into 1000 in the resolution and it is reduced to 250 into 250. Okay, so here is less detail, but it is smaller in size. Okay, so let's move further to the image quantization. So till now we have talked about the sampling. So now the time is talk about the image quantization. Okay, so it is the process of mapping continuous continuous your continuous intensity value into discrete gray level. Okay, so here the number of levels depends on the bit per pixel, which is BPP. So your one bit is equal to two levels, which is your black and white. Black and white. Okay, your 8 bit is equal to 256 level, which is your standard grayscale. A standard grayscale. Okay, and your 24 bit is equal to almost 16 million colors, which is your RGB image. Okay, so let's take an example. So a gradient from a black to white will look smooth in 256 levels. So if reduced to only 4 levels, it appears like white sharp band. Okay, so now we'll talk about the sampling versus quantization. So in sampling, we control the spatial details. Okay, and in quantization, we control the gray level details. Okay, so the next is like aliasing. So it is a important concept. So if sampling rate is too slow, false pattern appear in the image. Okay. So for example, a stripped shirt in a photo may produce like weird pattern when drawn sampled. Okay. So solution is like sample at the above Nyquist rate. So it should be like f of s is greater than equal to 2f of max. Okay. So let's talk about the importance in digital image processing of these things. So basically, the correct sampling and your quantization ensures like the good image quality and your efficient storage or your no false of artifacts. Okay. So let's discuss the key takeaway from the video. So it is sampling, which is choosing pixels in a space, which is your resolution, and the quantization, choosing the intensity levels to gray at your color levels, and poor sampling is aliasing, and more bit per pixel is your better quality but higher storage cost. So that's how the real world images are converted into the digital forms through sampling and quantization. So these two processes decides a resolution, quality, and the storage size of the digital image. So in the next video, we shall go one step further and discuss the basic component in sampling and quantization, including the practical issues like aliasing and how resolution impact on the image clarity. So tab tak liye, keep learning and keep exploring. Don't forget to like, share and subscribe my YouTube channel. Tab tak liye, keep learning and keep exploring. Bye bye.